Next concept is overvoltage due to switching surges and the system faults and other abnormal conditions. Means we are discussing that what are the responsible for the formation of the switching surges and because of opening and the closing of the switches, why it is so important, and we are going to make the discrimination between at the lightning and the switching surges. That's coming to that introduction part. So till the time of the transmission voltages, if it is around 220 kV and below, so over voltages due to that lightning of very high order, and the voltages which are generated inside the system are not much considered. So in the later, when we develop the system voltages means we are increasing the system voltages because of to increase the efficiency of the system. So let's say if it is for 400 kV, the over voltage generated which is inside the system, which is going to reach and the same order of the magnitude as that of the lightning of the over voltages. Okay, means we are giving the more importance for the switching surges of the voltage if it is greater than 400 kV. And the second thing is, whenever there is an over voltages which is generated and lost for longer duration, and therefore which is going to be in severe, and this is this is going to cause more dangerous to the system. So unless likely to the lightning, the over voltages, switching and other type of the over voltages mainly depending upon the system. Means that this the over voltage is not only depending upon the system, and also it is going to increase with the system voltage. That's what we discuss. So less than 400 kV, we are giving more importance for the lightning, and if it is greater than that 400 kV, we are giving the more importance for the switching surges. So while in the case of the insulation coordination and to protect the level of the any particular the devices like surge diverters and surge divestors, which is probably directly proportional to the maximum system voltages, and the insulation level and the cost of the equipment mainly depending upon the magnitude of these over voltages. Whereas in the case of extra high voltage range, the switching surges and other type of the over voltages, that is going to determine the insulation level of the lines and other equipments, and consequently they also determine their dimension and the cost. That's nothing but we are giving, as of nowadays, we are giving more importance for these switching surges and for the lightning as well because of the increasing in the system voltage. Then what are the origins of the switching surges? What are the responsible, or what are the sources for the origin of the switching? Okay, so when we are making a when we when we are making opening and the closing of the switches, like this is a switch. Okay, so we know that whenever the t is 0 means the time of okay, the switching time which is going to be 0 and at the infinity. Okay, these are the two probability which are going to consider that, because we discussed that when making and the breaking of the switches at inductor is at 0 and the capacitor is 0 and at infinity, that we understood that this is the same way which is going to act, because the transmission line itself, it having the some inductor and the capacitance behavior, that we have to be taken into consideration. Okay, so this is nothing but the making and the breaking of this electrical circuits and the switch case may be resulting in there is a formation of abnormal over voltages in the power system. So because of this having the large value of the inductance and the large value of the inductance and the capacitance which is associated with that, sometimes this over voltages, okay, this may be high, has 6 times that of the power frequency of the voltages. So whereas in case of the circuit breaking operation, switching the surges with the high rate of rise of the voltage, which is going to cause a repeated restriking of the arc between the contacts of the circuit breakers. So thereby, um, which is going to cause a destruction of the circuit breaker of the contacts. Hence, the switching surges may include a high natural frequency of the system, and sometimes it may be consisting of damped normal frequency of the voltage components. So, or restriking and recovery voltage of the system with successive reflected waves from the terminals. So, in other words, what we can understand is opening and the closing of the circuit breakers, which will cause the inductor and the capacitance behavior, and the circuit breakers, because of this property, means this is a CV where you are considering the restriking voltage subjected to the normal frequency, and high frequency is also causes some the formation of the origin of the switching surges in the system. Then we need to understand what are the characteristics of the switching surges. So mainly this wave shape of the switching surges, it is quite different, and may have the origin from any of these following sources. So here there's nothing but these are responsible for the formation of the characteristics of switching surges. That is nothing but de-energization of the transmission lines like cables, shunt capacitors, and the banks of the capacitors, means banks of the capacitors, etc. So these are the things we are going to consider. Then like disconnection of the unloaded transformers and reactors, etc. The transformer itself will behave like the inductors, and the inductors behave as of the transformers and the reactors. And next we have energization of the reclosing of the lines and the reactive loads. So generally we'll call it as GOST, gang operating of the switches. And we have sudden switching of the loads. Okay, so how it is going to behave to the system. And we have short circuit and the fault clearance, like line to ground, double line ground to ground, and what is the procedure of that. And then we have a resonance phenomenon like ferro resonance and arcing grounds. The ferro resonance is nothing but we are going to insert some of the capacitance in the distribution system. So these are the superimposed oscillation which is going to act with respect to the power frequency of the system. So then this effect, how it is going to cause the how it is going to cause the effect on the shaft of the generator. So these are the things we are going to discuss. So however, this a typical wave shape and the switching surges which is going to show here. So from this figure, what we can understand that it is clear that so these over voltages are irregular and can be of the high frequency or the power frequency with its harmonics. So this relative magnitude of the voltages may be of around 2.4 per rad. Per rad is nothing but actual value and the base value. In the case of the transformer energization, it will be around 1.42, that the 2 times of the per rad in the, whereas in case of the switching transmission. So these are the different wave shapes of the switching surges where we are considering that. Okay, the first one is the recovery voltage after the fault clearing. Okay, this is after the fault clearing. Just we can see to that it is high as the peak value will be of around 3 per unit, and when there is a fault initiation which is going to take place, that the per unit value will be high as around 2 per unit and varies till 1 per unit value, and the overload is at the line and after the fault clearing. So at the beginning it will be minus, and there is some damped oscillations. And if it is a case of energization of the long transmission lines, okay, so this is high as 3 per unit values, and if it is over voltage at the line end during, so it is varies from around 1 per unit value to the 2.5 per unit values. From this, what we can understand this, there is no linearity between one study to the another study. So that's why this is behavior like a non-linear structure. So studying of this behavior, it is very important when subjected to the over voltages, especially in the case of the extra high voltage and the ultra high voltage uh, of the system transmission voltages. So now we are going to discuss the switching over voltages in the case of EHV and the UHV system, extra high voltage and the ultra high voltage system. So we know that the insulation has the lowest Braidon strength for the switching surges if they do have larger air gaps. That we understood, that is a well-known concept. Further, if we have switching over voltage of having a higher magnitude as compared to that the lightning over voltages for UHV system. So whereas in the case of the over voltages which are going to generated in the EHV system, so when there is a sudden releasing of the energy, that is nothing but the internal energy which is stored either in the formation of electrostatic or electromagnetic form. The different situation under which this is going to happen is summarized as below. That is nothing but the first one is interruption of the low inductive current by high speed circuit breakers. So this is going to occur when there is a transformers or reactors are switched off. Then next one we have interruption of there is a small capacitive current such as switching off of the unloaded lines, etc. Then we have ferroresonance condition. That's what I told you now. So this we are going to insert some of the capacitor which is in series with the transmission lines. So how it is going to behave with respect to the load and the generator. Then we have energization of the long EHV and UHV lines. So these transient over voltages in above these cases can be of the order of around 2 to 3 per unit value and will have the magnitude of the voltage around 1200 kV to 2000 on 750 kV of the system. So this duration of these voltages varies from 1 to 10 millisecond depending upon the system parameters of the L and the C. That's not the inductor, the capacitors. From this, what we can see here is there are some comparable magnitude or even higher than those that which is going to occur during the lightning. So sometimes the over voltage may be lost for some several cycles. So other situations of the switching that is going to give rise to of the voltage around of the short duration 0.5 to 5 millisecond and having the magnitude of the lower is 2 to 2.5. That's nothing but over voltage of the short duration of the 0.5 to 5 millisecond and there is a lower magnitude will be of around 2 to 2.5 per unit. Some of the examples are which is going to give that's not the 0.5 to 5 millisecond and 2 to 2.5 per units are like single pole closing of the circuit breakers. That's nothing but whereas in case of if there is a fault in the system, then interruption of the fault subjected to the line to ground or line to line fault which is going to clear. So these are the examples. Then resistance switching which is going to use in the circuit breakers of the opening and the closing of the circuit breakers and the switching lines terminated by the transformers, okay, isolation transformers or isolation switches. Then series capacitors compensator which is going to use it for the long transmission lines. Then we have sparking of the surge diverters which is located at the receiving end of the line to limit the lightning over voltages. So these are some of the examples which is for the lower magnitude of 2 to 2.5 per unit values. So the other voltages, there is nothing but other over voltages due to that above the conditions are going to study, are going to calculate it from these factors. So that's nothing but we are going to make a mathematical modeling of the system using digital computers Okay, this is nowadays we have different softwares to analyze these kind of things. Then we have scale modeling using transient network analyzer. So like a MATLAB, and we are going to simulate all the things. So other than these things, we can make by conducting some field test to determine the expected maximum amplitude of the voltages and duration at different points on the lines. That's nothing but we have some cladonograph and Hall effect generators. Okay, all the different methods we have. Generally, we are going to insert in the transmission lines. After the season get over, that's nothing but rainy season get over. We will get back that. So in the laboratory, we are going to analyze that depending upon the a time constant. We could be able to analyze that what is the magnitude of the lightning and order of the lightning which is going to take place at a particular zone. Okay, so these are all the field survey which could be able to do it. So from this, what we are going to understand, that's what. So from this, the main factors that are going to investigated in the above studies are, we are going to understand the effect of the line parameters like a capacitors and shunt reactors, and what is the magnitude and the duration of the transients. Okay, and also from that we can capable to understand what is the damping factors which is going to need it to reduce the magnitude of the over voltage. So like reactors and the series, there's nothing but shunt reactance and series capacitors to minimize this effect. And to know that what is the effect of a single pole cooling, sorry, single pole closing, restriking, and switching with the series resistor or circuit breakers on the over voltage. So based on this, we can understand how what is the time total time of duration in which the circuit breaker is going to act, and what is the probability of the restriking voltage which is going to sustain for the sustain across the circuit breaker or the point of the contact of the circuit breaker and the isolating switches. And we are going to understand that the lightning arresters, the spark over castics, different castics, we are going to investigate it from these studies. So it is very necessary that in the case of EHV and the UHV of the system, to control the switching surges or to minimize within 2.5, sometimes it will be less than probably of the 2 per unit value or even less than that. So some of the measures which are going to taken to reduce the over voltage, because if this is the over voltage is much more than, if it is greater than the 2, it is going to cause much effect on the system. That's why we are going to limit this switching surges in the transmission lines. Some of the steps means the measure which you are going to take to reduce the over voltages are, there's nothing but of one step is of multi-step energization of the lines by pre-insertion of the resistors. So there's nothing but in place of the directly opening and the switching of the line, just we will insert some of the resistance which is in series with our line. Then we are going to make the energization. This is why we are going to make this resistor to limit the current in the transmission lines. Okay, then we have phase controlled closing of the circuit breakers with the proper sensors. So that's nothing but if we could able to close these circuit breakers with a proper phase sequence. Uh, so this is the one of the greatest achievement by some digital devices to multiple closing and opening of the circuit breakers. Then we have drainage of the tapped charger on long lines before the link before reclosing of the lines. So this is one of the greatest greatest means the greatest way of doing this, because many linemen they are losing the life because of the energy which is stored in the transformers and the long transmission line, which is going to cause the effect not only the person who is going to operate, and also which is going to affect on the system because of the superimposed oscillations. So that's why we will drainage the tapped charge. Then we are going to close the lines. Then we have some limiting the over voltage by using the surge diameters. So these are the some of the measures which are going to take to control the reduce the over voltage within the 2 or 2.5 per unit time of the values. So this is the table which is going to give the summary of the overvoltage that is going to develop under various conditions which is given below. So the maximum value of the system line to ground voltage will be considering it is 1 per unit value. So if this is a serial number and this is the type of the operation, and what is the per value of the voltage. If there is a switching an open-ended line with, considering the first case is infinite bus as a source with the trapped charges on the line. So just to see to that there is an voltage, the over voltage will be of around 4.1 per unit value. If this is infinite bus as a source without any trapped charges, okay, this will be around 2.6 per unit. If there is a de-energizing an unfaulted line with a restrike in the circuit breakers, so we can able to limit the voltage around 2.7. And if there is a de-energization an unfaulted line with a line to ground fault, considering this is the medium length of 1.3 times of the over voltages. So second condition is switching a over voltage, switching the voltage of 100 kV line through a auto transformer of 220 bar 50 kV of the LV side. Just to see that this is the over voltage will be 2 times. And if there is a switching a transformer a terminated line will be of 2.2. And if you considering that the series capacitor compensated line with 50% is the compensation, the magnitude will be 2.2. And the capacitor compensated with the shunt reactor compensation. This is the reactor compensation will be greater. This is resulting in there is an over voltage will be high. It is also 2.6 times. If there is a high speed reclosing of the line after the fault clearance, this magnitude will be 3.6. So among this, if there is an infinite bus with the trapped charges, the over voltage will be high, and the de-energization of the unfaulted line with the line to ground will be very less.